Thank you so much for joining me today. We will cover the last part of friction, part number 3. I am going to talk about first about wedges. Sometimes we have a body rested on this wall and this ground surface. I would like to move this body with the weight W up. So I can use a technique which is called wedges. I can push a little part here. This part will move to right, pushing this body up. This is the meaning of wedge. That makes sense? So a wedge is a simple machine that is often used to transform an applied force into much larger force directed at approximately right angles to the applied force. So if you push this wedge with a horizontal force, this wedge will push this body up. So the wedge will create movement perpendicular to the applied force. Does that make sense? So, and keep in your mind, I believe this pushing force P will apply a bigger force on this block. Does that make sense? So this is the topic for our meeting today. And we have another part which is talking about flat belts. So wedges also can be used to move or adjust heavy loads. And keep in your mind, most of the time we are going to use two equations of equilibrium, summation f of x equals 0, summation f of y equals 0. But be careful. When you are pushing this wedge with the force P, we have a contact between this surface and this surface. So we have friction. And also we have a contact between this surface. I'm sorry, what? Just a moment. And a contact between this surface and the ground surface. And also, if this block is moving up, we will have a contact between the surface of the block and the wall surface. So keep in your mind, if you have contact, just a moment, I'm sorry. If you have a contact and the relative movement between these two surfaces in contact, we should expect a friction. And this friction equal mu time capital N. And this capital N will be a perpendicular force to the surface of contact. This is what we learned at the beginning of this module. So, for example, if you are pushing this wedge to right, we have a contact here on this inclined surface. So, I will expect friction and I will expect normal force to the perpendicular to the surface of contact for the wedge. And keep in your mind, we have a good relationship between this force and this force. F2 will equal mu time capital N2. Because we have two parts and we have friction in between, so we have coefficient of friction, mu. If you multiply this mu by the normal force or the perpendicular force to the surface of contact, I can get the friction force. And keep in your mind, the direction of this friction force must be opposite to the direction of movement. Since you are pushing this wedge to right, so the movement will be to right. So I expect friction here on this surface to be opposite. The same, we have a contact here between the wedge and the ground surface. So I should expect friction opposite to the movement direction, and I expect perpendicular force. If the perpendicular force is N1, the friction force will be F1. This F1 equal mu time N1. That makes sense? So be careful and be smart. The direction of the friction will be opposite to the direction of movement. The value of this friction will equal mu time capital N. Capital N is the perpendicular force to the surface. If your surface is horizontal, the perpendicular force will be vertical. If the surface of contact is inclined, the force capital N will be perpendicular direction. That makes sense? So this is a very important point. This surface is inclined. So the capital N2 is perpendicular to this surface. This surface is horizontal. So the direction of N1 is perpendicular to this surface, which is vertical. At this surface also on the block, the friction force will be in opposite direction. The perpendicular force will be in opposite direction. The same values, but in opposite direction. So F2 will be here of F2, but in opposite direction. Capital N2 will be here, capital N2, but in opposite direction. And keep in your mind, since this block will move up, so I should expect here friction. This friction will be in opposite direction for the direction of movement. The block is moving up, so the friction will be down. And we have perpendicular force to the surface of contact. And keep in your mind, this friction force F3 will equal mu time capital N3. Any friction will equal mu times the perpendicular force at this surface, capital N. I'm not sure, no, not all the time, but sometimes they are different. I'm not sure if this mu is the same like this mu is the same like this mu, because you are, can you see we have different two components. Here we have contact between the wedge and the ground surface. Here between the wedge and the block. Here between the block and the wall. Sometimes the coefficient of friction is different. Sometimes all of them is the same. That makes sense? This is how to draw the free body diagram for the wedge. Let's do an example. Let's do an example and see what's going on. I would like to start with this one. Then I will go back to example number 1. We have a block. This block has a weight equal to 100 Newton. I would like to push or to lift this block up. So I have a wedge here, and I'm trying to push this wedge below or under the block. And we are given the coefficient of static friction between all surfaces of contact, between the block and the wall, between the block and the wedge, between the wedge and the ground surface. All of them will have the same value, coefficient of friction equal 0.3. The question is, what is the force P that must be applied here to be able to push this wedge to left and to lift this block up? That makes sense? So determine the force B that must be applied to the wedge in order to lift the block having a weight of 200 Newton. So keep in your mind, this problem will be solved by analyzing the wedge and analyzing the block. Let's start with the wedge. Here is the wedge. We are trying to push this wedge with a force P. 100% I believe there is a friction force between the wedge and the ground surface at C. This friction force, I will call it FC, will be in opposite direction for the direction of movement. Since the applied force trying to push your wedge to left, FC will be to right. And also 100% I have perpendicular force to the surface of contact, will be called capital N at C. So far, so good. And also, I believe 100% that FC will equal mu time capital NC. I can remove mu and put 0.3, so the value of FC will equal 0.3 NC. Anybody in this room so far, do you have any question? Do you have any question about the friction force between the wedge and the ground surface? And the value of this friction force in a function of the value of capital NC, which is perpendicular to the surface of contact. Also, since you are pushing this wedge to left and this block will have a friction with the wedge. So we have friction between the wedge and the block. This friction will be in the opposite direction for movement. Since the movement is going to left, to the direction of left, I should have here a friction called F at point A. And I should expect normal force to the surface of contact, capital N at A. Does that make sense? Do you have any question so far? So keep in your mind also this friction force at A will equal mu times capital N at A. So FA will equal 0.3 capital NA because the value of mu is 0.3. Do you have any question so far? Nothing else we can do, or nothing, no forces we can apply. If you have any question, just let me know. I forget to mention we have missing something here. This angle alpha equal 5 degrees. This angle should be given. So keep in your mind that this angle alpha will be the angle for this force and will be the value for this force. Alpha equal 5 and the alpha equal 5. So if you apply summation f of x equals 0 for this wedge, I have in x direction negative p. I have in x direction FC, which is positive, 0.3 capital NC. Keep in your mind, FC equal 0.3 NC. In x direction, I have FA cosine. And FA equal 0.3 NA cosine 5 degree. In x direction, I will have NA sine alpha, which is 5 degree, equal 0. Does that make sense? If you apply summation f of y equals 0, guys, keep in your mind, this capital N will have a component in a vertical direction and the horizontal direction. The horizontal one will be NA sine alpha, which is 5. And this FA will have a horizontal component, which is FA cosine, and FA equal 0.3 NA, so 0.3 NA cosine. If you apply summation f of y equals 0, in y direction we have NC, in y direction we have negative NA cosine alpha. In y direction we will have positive FA, which is 0.3 NA sine alpha, which is 5, equal 0. This alpha equal 5. So I applied the two equilibrium equations, summation f of x equals 0, summation f of y equals 0 for the wedge. So the first step, I draw the free body diagram for the wedge. We have applied force. We have friction between the wedge and the ground surface. We have friction between the wedge and the block. And this friction will equal mu time capital N. So I apply summation f of x equals 0, all forces in x direction. Summation f of y equals 0, all forces in y direction. Looks like we have two equations, but these two equations in three unknowns. I cannot solve them. No way to solve them mathematically. So I have to work with the block. Let's start to work with the block. For the block. Here is your block. Keep in your mind, first of all, this block has a weight equal to 100 Newton, I think. 200 Newton. This block, under the effect of the wedge, which is moving to the left direction, this block will be lifted up. So the direction of the movement for this block will be up. So I expect friction down. This friction will be called FB. And I have, because we have friction, we have normal force, we have perpendicular force, capital NB. And keep in your mind, this FB will equal mu time NB. So will equal 0.3 capital NB. This is the force FB. That makes sense? Keep in your mind, because we have contact between the wedge and the block, these two forces, FA and NA, will be in opposite direction, like this and like this. That makes sense? So FA moving to up, FA will move down. NA coming to down, I'm sorry, we have a mistake here. NA will be in this direction, opposite direction. Sorry, guys. This is the direction of NA. Since your wedge was something like this, and the FA was like this, and the NA was like this, so the two forces will be in opposite direction, same values, but in opposite direction on the block. That makes sense? Keep in your mind also, this FA equal 0.3 capital NA. That makes sense? If you apply summation f of x equals 0, what forces do you have in x direction for this block? I have capital NB. I have this is the angle alpha equal 5. Yes. And this is also the angle alpha. So for the x component, I will have negative FA, which is 0.3 NA cosine 5. And also for the value of NA, I will have negative NA sine 5 equals 0 for the x direction. Keep in your mind, if you'd like more clarification, I can tell you this is the direction of NA. This is the angle alpha. So NA will have two components, one like this and one like this. This one will be NA cosine alpha. This one will be NA sine alpha. The x component will be negative NA sine alpha, which is 5. Does that make sense? Also, for the second force, which is FA, this is the angle alpha. So this value of FA will be FA cosine alpha. And we have a component here, FA sine alpha. For the x component, it will be FA cosine alpha. FA cosine alpha. And your value of FA equal 0.3 NA. That makes sense? So you can simplify this equation more. Positive NB, negative. Just a moment, looking for my calculator. 0.3 cosine 5 plus sine 5. I got here negative 0.38 NA equals 0. Also, I will apply summation f of y equals 0. What forces do you have in y direction? We have negative 200. This is the weight. We have negative FB, which is 0.3 NB. We have also the y component for NA, which is NA cosine 5. We have the y component for FA, which is negative FA, which is 0.3 NA sine 5 equals 0. So we have y component, y force for this FB, y force for the weight, y component for FA, y component for NA. I can simplify this to be negative 200, negative 0.3 NB, and cosine 5 minus 0.3 times sine 5 equal positive 0.97 NA equals 0. If you look to this equation and this equation, I have two unknowns in two equations, NB and NA. I can solve them together. So from this one, I can say NB will equal 0.38 NA from this equation. You can substitute NB with this value. So negative 200 minus 0.3 times NB, which is 0.38 NA, plus 0.97 NA equals 0. From this equation, I think I can find out the value of NA. The value will be 233.6 Newton. I can go back and find the value of NB. It will be 88.8 Newton. So from the equilibrium, from the analysis of the block, I figured out the value of NA and NB. I can go back here and put the value of NA 233.6. I can put the value of NA 233.6. I think the value of NA here 233.6. I think I can find out the unknowns. If you look to this equation, the only unknown is NC. So I can figure it out. So negative 233.6, the value of NA times cosine 5 plus 0.3 times 233.6 times sine 5. So the value of NC will be 226.6. If you go back to this equation and put the value of NC 226.6, the only unknown here will be the force P. So the force will be 137.8. Let me check it one more time. Yes. So I need to apply a force here, 137.8 Newton. This force will be able to lift the block which has a weight equal to 100 Newton. That makes sense? So how to solve this kind of problem? I have first to analyze the wedge. What forces do you have on this wedge? And then I need to analyze the block. For each two parts, I need to apply the two equilibrium equations, summation f of x equals 0, summation f of y equals 0 to set up your equations. In the second part, I need to apply the two equilibrium equations, summation f of x equals 0, summation f of y equals 0, to set up two equations. Solve these equations together. You can find out the unknowns. Do you have any question from this equation? This is the typical problem you will have in this part. This is the typical one. We have another example here, which is a combination between what we are covering today and something we covered before. So we have a uniform stone shown has a weight 5,000 Newton. The weight of this stone is 5,000 Newton and is held in the horizontal position using a wedge at B. So looks like we are supporting this stone with a wedge at B. If the coefficient of static friction is equal 0.3 at the surfaces, all surfaces, whatever the two surfaces of contact, we need to figure out the minimum force P needed to be applied to the wedge to remove the wedge. We are trying to remove the wedge from under the stone. Can you tell me how much minimum force we need to apply? Does that make sense? So we have assumption here that the stone will not slip at A. So this point is fixed, no slip at A. So if you look to this problem exactly like we did in the previous example, we have two parts, the wedge and we have block, but the block here has a different configuration. So also I will start talking about the wedge. Here is your wedge. I'm sorry. Your wedge looks like a triangle. We have applied force here, P. I think this applied force will remove the wedge to right. So the direction of movement will be to right. So I expect a friction here. F at C. I have normal here, capital N at C. Keep in your mind, this friction force at C, which is in opposite direction for the direction of movement, will equal mu times capital N at C. That means this force will equal 0.3 NC. That makes sense? Also, the direction of movement of this wedge will be to the right. So I expect a friction between the block and the wedge opposite to the direction of movement. And I have normal force to the surface of contact. Looks like this direction, capital N at B and the friction at B. Keep in your mind also, this friction at B will equal mu times capital N at B, which equal 0.3 also NB. So this force equal 0.3 NB. Nothing else at this wedge. Nothing else. So I can start to apply the two equilibrium equations, summation f of x equals 0 and the summation f of y equals 0, and see what will happen. Does that make sense? So keep in your mind, this angle is given 7 degrees. So if you apply summation f of x, we have positive b. We have negative FC, and the FC equal 0.3 NC. We have also the x component for FB, which is FB cosine 7 negative FB equal 0.3 NB cosine 7. Keep in your mind, guys, this term represent FB cosine 7. This is the x component for this force. Also keep in your mind the angle between the vertical direction and this force in B is alpha also, which is 7. So I will have positive NB sine 7 equal 0. This is the first equation. Second equation. Summation f of y equals 0. We have positive NC. And we have the x component, the y component for FB will be negative FB, which is 0.3 NB sine 7. Keep in your mind, this term represents FB. And we have also negative NB cosine 7 equals 0. Looks like we have two equations, but the two equations in three unknowns, capital P, NC, and NB. Unfortunately, mathematically, I cannot solve. Exactly like we did in this part. We have the wedge. I set up my friction forces, perpendicular forces, applied my equilibrium equation, summation f of x, summation f of y. I set up two equations in three unknowns, exactly like I did here. For the wedge, the same. And I apply two equilibrium equations. I set up two equations in three unknowns. Then I need to analyze the block. Here is the block. This is the block. We have a weight here, 5,000 Newton. And I think at the contact B, I will have a force in opposite direction, which is called FB. Remember, the force FB on the wedge will be in opposite direction on the block. And the force in B perpendicular on the wedge like this, so it will be like this. That makes sense? And we have point A. I don't like to pay more attention about point A to try to avoid any complication. So keep in your mind that this angle alpha, which is 7, and this angle alpha, which is 7. Does that make sense? And keep in your mind, if B is already equal 0.3 in capital B. Does that make sense? I think I don't like to apply summation f of x, summation f of y for this block because I will go through what is going on at A. So I don't like to make it more complicated, but if you want, that's fine. Let's try. We have here friction. Because if you move the wedge to right, probably this block will move to right. So the friction will be in opposite direction FA, and we have here perpendicular to the surface of contact capital NA. And keep in your mind also this FA equal 0.3 NA. If you apply the two equilibrium equation summation f of x equals 0, I will have 0.3 NA negative direction, this force FA, and I will have the x components for these two forces, which is negative NB sine alpha, which is 7, and I have positive FB, which is 0.3 NB cosine 7 equals 0. You can simplify this one will be negative 0.3 NA And we have negative sine 7 plus 0.3 times cosine 7. I got plus 0.17 NB equals 0. This is the first equation. If you apply summation f of y equals 0 for this part, what forces do you have in y direction? I have positive NA, I have negative 5,000, I have positive NB cosine 7, I have positive FB, which is 0.3 NB sine 7 equals 0. For each of these two forces, we have x and y component. We can simplify these equations. So I can say positive NA minus 5,000 plus cosine 7 plus 0.3 times sine 7 equal 1.03 NB equals 0. So I have two equations in two unknowns, this one and this one. I can solve them together. So from this equation, I can say NA will be 0.17 divided by 0.3 NB. Go back here and put the value of NA with this value, you can find the value of NB. That makes sense? So 0.17 divided by 0.3 plus 1.03, this is plus, divided by 5,000. So the value of NB will be 3,131.5. If you go back here and put NB this value, the value of NA will be NA 1,774.5. If you go back to the first part for the block, for the wedge, I'm sorry, the value of NB 3,131.5. 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 I think from this one I can find out the value of NC. So the value of NC will be 222.6. That makes sense. If you put the value of NC here, 3,226.6, I can find out the value of P. So the value of P will be 1,517.6. So the minimum force I can apply on the wedge to remove the wedge from under the block is 1,517.6 Newton. So if you look to this problem and the second problem, I did the same. I started first with the wedge. I applied the two equations to set up two equations. I'm sorry, I applied the two equilibrium equations to set up two equations. Then I did analyze to the block part, and I applied also the two equations to set up two equations, the two equilibrium equations to set up two equations. Also, what I did here, I did the same. I have two parts, the wedge and the block. The wedge, I have forces. I apply the two equilibrium equations to set up two equations. Then for the block, I have contact between the block and the surface at A. And we have two forces opposite to the two forces on the wedge. I applied the two equilibrium equations, summation f of x equals 0, summation f of y equals 0. I set up two equations. I solved these two equations together to find out the forces. I went back to the first part for the wedge, put my forces values, and I found out the value of the force P.